1. Task introduction. In industrial automation systems, servo drives are the core devices for achieving precise motion control. This lesson uses the Kinko FD423LA000, model CD423AA000 servo drive as an example, providing a detailed explanation of its electrical parameters, interface functions, wiring specifications, and control logic. The content offers technical guidance for equipment commissioning in applications such as automated parking systems. 2. Learning objectives. 1. Parameter awareness. Understand the drive's input voltage, single-phase 200 to 240 volts AC plus or minus 10%. Output specifications, 3-phase 0 to 240 volt AC 4.0 amperes. And power capacity, supports driving a 750 watt motor. 2. Functional operation. Comprehends 6 operating modes and their applications. Position, velocity, torque, pulse follow, full closed loop, and homing. 3. Hardware configuration. Identify drive interface layout. Power terminals X2, control interface X4, encoder interface X5. Master DI switch, SW1 to SW8. Settings for station address and termination resistor configuration. 4. Wiring specifications. Follow single-phase 220 volt power wiring procedure. MCCB and FMC. Correctly connect pulse control signals, MA plus and MA minus, MB plus and MB minus, and the encoder interface X5. CD3 series servo drive. The automated parking system uses the Kinko FD423LA000 servo drive, model CD423AA000, as shown in the figure. This drive accepts a single-phase 200 to 240 volts AC input, plus or minus 10% voltage tolerance, and converts it into a 3-phase 0 to 240 volts AC output through high-efficiency rectification and inverter technology. The rated output current is 4.0 amperes, with a peak instantaneous current of up to 6.0 amperes, capable of driving a 750 watt servo motor. The drive's control power, L1C and L2C terminals, is independently supplied to ensure stable operation of the logic circuits. The drive features a built-in intelligent power module, IPM, achieving 96% energy efficiency through 15 kHz PWM combined with vector control algorithms, converting single-phase AC into 3-phase variable frequency AC to drive the motor. It offers 6 operating modes. Position mode supports closed-loop control with 17-bit high-precision encoder feedback, with a minimum control unit of plus or minus 1 pulse. Velocity mode features built-in trapezoidal acceleration and deceleration profiles, supporting precise speed control down to 0.01 revolutions per minute. Torque mode provides constant torque output, suitable for tension control applications. Pulse follow mode supports differential pulse input up to 4 MHz. Full closed-loop mode allows connection of an external linear scale to enhance positioning accuracy. Homing mode provides 23 zero-seeking strategies to accommodate different mechanical structures. The Kinko CD423 servo drive features a compact industrial design, 40 mm x 40 mm x 10 mm, with a metal housing that provides both EMC protection and heat dissipation, as shown in illustration. The front panel is divided into 3 functional areas. The top status display area is equipped with a 4-digit LED to show parameter codes, e.g. F001, and operational values in real time, with a 5th dot indicator flashing to indicate that the drive is enabled. A tricolor LED system visually indicates status with green RDY, ready, yellow run, running, and red ALM, alarm. The central interface cluster is designed to prevent misconnection and includes an 8-pin power terminal, X2, supporting single-phase 200 to 240 volts AC input and 3-phase motor output, max 4.0 amperes. A 36-pin multifunction control interface, X4, integrating 7 opto-isolated digital inputs, 5 relay outputs, and plus or minus 10 volts analog input channels, and a 6-pin encoder interface, X5, specifically for absolute encoders. The bottom honeycomb-shaped heatsink structure, greater than or equal to 60% open area, combined with natural convection channels, ensures stable operation in ambient temperatures of 0 to 40 degrees Celsius. The 8-position DIP switch on the device side, SW1 to SW8, allows binary encoding for setting the device station number, with SW2 dedicated to configuring a 120 ohms termination resistor. The communication interface, X10, uses a 5-pin pluggable terminal supporting dual protocol transmission via CA-NOPN and RS-485. In terms of safety design, the housing features laser-etched triple markings, a high-voltage warning clearly stating, "Do not touch terminals when powered," CE EN 6180051, and UL E492798, certifications ensuring compliance with international safety standards, and an IP20 protection rating effectively preventing ingress of solid objects. The interface covers use a snap-on quick-release design, and the red power terminals contrasted with blue signal terminals significantly reduce the likelihood of wiring errors in the field. The figure illustrates the standard external wiring scheme for Kinko CD3 and FD3 series servo drives under single-phase, 220-volt power. It clearly shows the complete power supply circuit. First, the power input is connected through a circuit breaker, MCSP, for overcurrent, short circuit, or undervoltage protection. Next, a noise filter, NF, is installed downstream of the breaker to suppress grid interference. Finally, a magnetic contactor, MC, serves as the main power switch, with its coil equipped with a surge suppressor to absorb back electromotive force. The figure specifically highlights the wiring details for the servo drive's power terminals, X2. L1 and L2 connect to the single-phase 220-volt live and neutral lines, while the PE terminal must be reliably grounded, grounding resistance less than or equal to 10 ohms. The diagram above shows the external input-output connections on X4. When using pulse control mode, the wiring is as follows. In pulse plus direction control mode, corresponding to your PLC program's Q0.0 and Q0.1 physical outputs, MA+, pin 27, and MA-, pin 29, serve as the main pulse channel, directly corresponding to the PLC pulse output terminal Q0.0. The pulse sequence sent from the PLC to Q0.0, up to 100 kHz, is transmitted to the drive through this differential pair, with each pulse triggering the motor to rotate a fixed angle, e.g. 0.001 degrees. The pulse frequency determines the motor speed, and the differential design of MA+ and minus effectively suppresses pulse distortion caused by electromagnetic interference in the field. MB+, pin 31, and MB-, pin 33, serve as the direction control channel, corresponding to the PLC direction output terminal Q0.1. The diagram above illustrates the physical layout and electrical definition of the encoder input interface, X5. On the left is a 6-pin rectangular connector with pins labeled 1 through 6 from left to right. Pin names /SD, clock minus, GND, plus 5V clock plus SD. The table on the right systematically explains each pin function, including plus 5V power input, pin 1, signal ground, pin 2, differential clock signals positive and negative, pins 3/4, and differential serial data signals, pins 5/SD and 6/SD. This lesson provides a detailed explanation of the core configuration of the Kinko CD423 servo drive. 1. Electrical specifications. Single-phase 200 to 240 volt plus or minus 10% input, 4.0 ampere output, driving a 750-watt motor, 15 kHz PWM. 2. 6 operating modes: position, velocity, torque, pulse follow, full closed loop, and homing, suitable for precision motion applications. 3. Interface layout: power terminals X2, single-phase power connected to L1 and L2, control interface X4, differential pulse pairs, MA plus or minus and MV plus or minus, encoder interface X5, differential clock and data signals. 4. Key operations: DIP switches, SW1 to SW8. Set the device address and terminal resistor. Pulse and direction wiring corresponds to PLC outputs.